Good evening, viewers. Welcome to Chamberlain Educational Channel with your anchorman, Uncle Chamberlain. In our introductory part last week, I made you to understand that I will be tutoring you on mathematics and physics. Today, I'm taking you on mathematics on the topic indices. Indices. What is the idea you have about indices? What I'm asking you as viewers, what is the idea you have about indices? Indices is simply a base number when raised to a power forms an index. A base number when raised to a power forms an index. A base number when raised to a power, an index is 4. E.g., number 1, x raised to the power of 2, an index is 4. 2, a raised to the power of n, an index is 4. 3, m raised to the power of n, an index is 4. And all this from 1 to 3, they are known as indices. Indices is a plural word, a plural form of an index. That is it. So if you understand indices, there is no mathematical equation that comes your way in indices that you cannot solve, most especially if you know the laws guiding indices. Now let's go to the law of indices, the laws of indices. Laws of indices. Laws of indices. Indices are being governed by laws. For you to solve questions involving indices, you must understand these laws completely. Law number 1. Law number 1 states that if x raised to power a plus x raised to power b, it is taking, being that they are of the same base, xx, we take one of the x. No, in this case it is a multiplication. Multiplication. If x raised to power a multiplies x raised to power b, what you do is to add their powers. If x raised to power a multiplies x raised to power b, you pick one of the x, which is the base, and you add their powers, which is a plus b. Provided x is not equal to 0. Provided x is not equal to 0. When you say provided x is not equal to 0, that is to say x is greater than 0. But it could be 1, it could be 2, it could be 3, it could be 4, it could be 5, it could be 6, and so on. But it is not 0. Then rule number 2. Rule number 2. In rule number 2, when you have an index, say x, if you have an index, say x raised to power a, x raised to the power of a is divided by another x raised to the power of b, This is an equation involving indices. What you do here is to pick one of the bases. You pick one of the bases, x, then you subtract the powers, b. This is your answer. What you have there, it will be x as a question. What you have as a question is x to power a divided by x to power b. So your resolve will be x to power a minus the power of b. You pick one of the bases, which is x. You know you have two x here. So you pick one of the bases, x, then you subtract their index, a minus b. That will give you answer. Then another law of indices states that, the third law states that when you have x to the power of minus a, this is the same thing as 1 all over x to a, x to a. You can check this. You can check this by the following. You can check this by the following. If you have an equation like this, x minus a, this is simply, this could also be written as x to the power of 0 minus a, x to the power of 0 minus a. And when you have x to the power of 0 minus a, this could further be written as x to the power of 0 divided by x to the power of a. And you know, when you are dividing, what you should usually have is, when they are dividing, what you usually have is x to the power of 0 all over x to the power of a. But we know that in indices, anything raised to power 0 is 1. In indices, any base number raised to the power of 0 is equal to 1. So from this equation, from the above equation, let's term it equation 1. From the above equation 1, x to the power of 0 all over xa is equals to b, the s to the power 0 is 1, is equals to 1 all over 1 all over x a. I don't know if you understand this properly. Is equals to x all over a to the power of a. So if you have an equation as this, if you have an equation as this, so if you have an equation as this, such as this, x minus power of a is same thing as 1 all over x all over a. This is proven from this check I just did. It's proven from it, from the check I did. So also we have another law of indices, law number 4. Law number 4 states that y states that x over y with an inverse index, this is same thing as y all over x. This is just a reverse. This was x all over y to the power of minus 1. But what you resolve to have is y all over s. You see that because of this, because of the fact that it's raised to the power of minus 1, you now have an inverse. There is an inverse. An inverse of this expression will be the result, will be the solution for this equation. An inverse of this expression will be the solution. This is the inverse. Here in the question you have x all over y raised to the power of minus 1. But the solution is y all over s. That is the solution. But I know as time goes on, as we study further, you people will be able to understand me properly. As we study further with examples, you will understand what indices truly is. Then law number 5, the fifth law. The fifth law. The fifth law. The fifth law states that x to the power of 0 is equals to what? Is equals to 1, provided x is not equal to 0. Provided the base number is not equal to 0. You can check this too. Using the following. using the following. Now, let's assume we have an equation like this: x to the power of 0, and it's proven to be equal to 1. How do we prove this? You know that x to the power of a minus a is the same thing as x to a divided by x to the power of a. Right? And this last expression could also be written as x to the power of a all over x to the power of a. X raised to the power of a divided by x raised to the power of a. If they cancel that, it will give you equal to 1. That is what we have proven, that x raised to power 0 is equals to 1. It's what we have proven, that x raised to power 0 is equals to 1. And how do you prove that? We know that x raised to power a minus the power of a will give you 0, because a minus a is what? 0. So if you minus a from here, a from a, x raised to the power of a minus a will give you 0, right? If that gives you 0, that is x now is raised to the power of 0. But x raised to the power of a minus a could be expressed also as x raised to a divided by x raised to the power of a. And if you go by the division, you'll see that x raised to the power of a divided by x raised to the power of a will give you what? 1. That is his answer. That is it. That is the solution to the question. Now, let's go further by solving some examples. We'll go further by solving some examples. Let's go further by solving some examples. Like in our first equation, I did mention that in our first equation, I did mention that what? That x to the power of a multiplied by x to the power of b is equals to what? X to the power of a plus what? B. Provided x is not equal to 0. Now, we can simplify this by saying 2x 2 raised to the power of 3 times what? 2 raised to the power of 4. This will give you what? 2, 3 plus what? 4. This is going to give you 2 raised to the power of 7. That's the answer. So also, if you have let's buttress the second command. If you have so also yes, so also if you have this is for the first example, for the first law. The second law, if you have say this for the first law, then the second law, if you have 22 n raised to power 7 divided by 2 n raised to power 4. When indices are dividing, what happens to their powers? The powers they subtract. So what you do here is you say 22 n raised to power 7 all over 2n raised to power 4. This will divide this is 11. So what you have is 11 n to power 7 all over n to power 4. When this n goes up, you now have what? 11 n 7 raised to power 7 minus 4. This will now give you what? This will give you 11 n raised to the power of 3. This is your answer. This is your answer for this. This is your answer for this. Yes, these are for this equation. Then let's go to further to look at the other law of indices. The other law of indices states that if a number is raised to the power of 0 is equals to 1, which is third law. If you have 9x to the power of 0, this is the same thing as 9 times x to the power of 0, which equals to 9 multiplied by 1, because x to the power 0 is 1, which is equals to 9 as your answer. That is it. Then the fourth law says that if you have x to the y inverse, this is the same thing as y over x. So if you now have an equation like this, say 8 over 24 inverse this is the same thing as 24 over 8, which equals to 3 as your answer. So these are basically the laws of indices, but time will not permit us to go into further examples. I will end here today. By the time we meet again, I will give you further examples on indices. I wish you the best of luck, and I enjoy you all to like, subscribe and comment on Chamberlain's educational channel so that it can come your way anytime. Thank you very much, and God bless. I'll see you some other time. Thank you.